Thank you very much for having us here. We're here because, well, we did have the support of the University of Porto to be here, for which we are very grateful. And it's a pleasure to be here at AIME 2021 to tell you a little cautionary tale on using COVID-19 data to train machine learning algorithms. So I was joined in this work by João Miguel Alves, João Manuel Marques da Cruz, and Professor Ricardo Cruz Correia, to all three of which I'm very thankful for their trust, and I hope I make it justice. So without further ado, I would just like to outline which is our agenda for today. So I prepared a brief executive summary for those who do not have the inclination to listen to the rest. I fully understand that, but for those of you who are very interested, I will go on into the rationale names, after that to the material and methods that we use, consequently to detailing the results of our paper and terminating with the discussion on the results which we obtained, of course. So to put it very clearly, we are all very aware of the need for good quality real-time epidemiological data to tackle pandemics. And COVID-19 is in no way different from that. And we need reliable data if we're training decision-making support mechanisms based on machine learning to aid, say, in hospital management or in public health units management. What we did was focusing on this last aspect and basically perform an assessment on the resources and tools used by public health professionals to gather COVID-19 data in Portugal until December 2020. We discovered several flaws which hamper the data quality that was collected, both at the workflow and at the data gathering methods that we have. So going forward, this clearly, we always have this sense that we have a wealth of data, tons of data being generated every time. But we must first ask the question, what is the process underlining the data that we're collecting? Because as we know, we need data that we can trust, robust data to fuel decision-making support mechanisms. And moreover, when we're talking about machine learning algorithms, which reinforce the behaviors of the data sets on which they are trained. And that was precisely what me and my colleagues aimed at doing here. We wanted to evaluate which resources they had, how they gathered this data, and how was effectively this management done by Portuguese health authorities from the onset of the pandemic until December 2020. Please bear in mind, there were two very different moments for these formularies, and we will discuss them at a later stage. We focus clearly on describing how data for COVID-19 is expected to be collected and managed by PHPs, meaning public health professionals, including the questionnaires used for epidemiological surveillance. Having said this, we basically mapped the work processes at the public health unit level, as well as relevant platforms, namely Synap. For those of you who are not Portuguese, Synap is basically our national epidemiological surveillance information system. And we performed the comparison and critical analysis of the initial notification form and epidemiological questionnaires, so both belonging to March 2020, against their updated versions from November 2020. We also did and dabbled with the metadata set possibilities that we had from DGS in order to make a few annotations which we believe would be of use as a going ahead kind of tip for public health authorities. So when it comes to the results, when you have a suspected case, there was a notification in Synap issuing the need for a test, and then the verification of the result of the test. Should the test prove negative, well, your public health professional would fill the epidemiological questionnaire, and after that, considering the patient negative, it would end. However, and I don't know if you can see my mouse, but here it is. So should the test go positive, the public health professional had to perform two tasks. First, fill the epidemiological questionnaire, this time claiming that the patient is considered positive for COVID-19. And second, you had to call the confirmed case, performing the contact tracing process. You had to evaluate and contact those which were deemed as risky contacts from that patient. So calling low risk contacts and explain the measures that they should take into account, or call high risk contacts and impose confinement measures. This implied issuing a prophylactic isolation declaration for those employed, or even for basically justifying any resort to public or private facilities, updating the information on another system, not Synap, but Trace COVID, on high-risk contacts, and I'll get into this later. And finally, communicating which people were isolated to both security forces and services, namely in municipalities, with the objective of basically guaranteeing that the confinement was assured. This then concluded the episode for a person considered positive. This, as you could already guess, is a bit of a burdensome work, right? But you have to take into consideration that first you have a notification form filled when someone is suspected of having it, and the epidemiological questionnaire when somebody is confirmed as having it. And guess what? It has tons of fields. So, but the problem is not only that it had tons of fields, it's how the fields were updated. So we did this search and we did verify that for the notification form, there were 19 questions existing only in the March 2020 form, which were removed in November. 3 questions which popped up in the November update and which were not present in the original March form. 1 question in both versions, but which was actually placed in different locations. And as we are aware, the place where if you put it actually can change the odds of answering one way or another. And the other thing that can affect those odds is precisely wording it differently. And we also saw that there was a question which corresponded to that criteria, let's call it that. So we could see that for the notification form in March 2020, we had 138 fields to fill, whilst in November 2020, it only had 120. And when it comes to the epidemiological questionnaire, we dropped from 62 to 53. Still pretty burdensome, don't you think? This is a little bit to give you a graphic highlight. So in green, you have those existing in March and removed in November. In purple, you have those non-existing in March and added in November 2020. In orange, those which were presented in different locations. And in yellow, those which were similarly worded, but not exactly the same way. Taking all this into account, first place, workflow processes. Clearly, the workflow process that was adopted was very fit for a place where you have a small number of cases, but it is not suitable for when you have a large number of cases. And I would just like to quote, and I'm not saying this by memory, but from March 16 to October 19, that's 217 days, we had our first 100,000 cases. It took us from October 19 to November 13, which is only 25 days, to have the 100,000 next cases. This clearly shows a jumping trend and one which should have prompted workflow processes to be rearranged. How could you do that? Well, first of all, the CDC recommended reducing intensity of interaction by public health professionals by simplifying communication methods. This can potentially reduce data quality, but first you acknowledge it, and then it can be justifiable in a pandemic scenario. Second, remove the redundancies in the information workflow. And as you can see, there's a big oops in there because not only did public health professionals have to report it when it came to Synap, but they also had to report to this other program called Trace COVID, which was basically ad hoc inserted. And finally, the integration of IT systems across a workflow chain basically becomes much harder, and also because of the changing forms. And there were clearly processes which were not automated. And Going to registry forms, just to make this a continuous line, changes in forms do not ensure consistency. This increases the uncertainty about the data which is being reported. It raises doubts about data quality, and it makes data integration much harder. Second, the second point is the lack of mandatory filling for some fields, as well as the lack of a clear indication of expected answers, mainly because of pre-populated answers, for example, leads to a potential loss of coherent data which you can easily export and train algorithms on. And when it comes to the metadata, which we dabbled in a little bit, first it considered the place of infection to be the place of residence. We know for a fact that this is not true. Hospitalization data, well, it was really dependent on the need for admission upon notification or correction. So basically, you had to be admitted into an hospital for a very serious case of COVID-19 to actually get hospitalization data registered, which is a little bit troublesome when you think about it, because many people go there with simple symptoms. And then you have the risk of underreporting of other variables. Well, you either make it mandatory or at least you acknowledge it. And I know it doesn't suit me very well to quote Donald Rumsfeld, but he once said that you have known knowns, known unknowns, and unknown unknowns. And the later are the ones which truly mess up the process. And the bottom line conclusion of our work and its major implication for planning is that we are not aware of what our known unknowns are, much less our unknown unknowns. Sorry for the little bit of a tongue stopper there. I really thank you for your attention, and we remain at your disposal for any questions and discussion that you might want to have. And I would just like to highlight once more that this work was done under the scope of and funded by the PhD program in health data science or the Faculty of Medicine of the University of Porto. And I do encourage you to check up our website. And if you're considering a PhD in health data science, we still have our applications open. Thank you very much.